1. Let's talk about circles. So a circle is a set of points in a plane at a given distance from a given point in that plane. The center is the given point. And the radius is the given distance. So here's the given point, and the radius goes out a certain distance, and that same distance is here and so forth, like spokes on a wheel. Except that one I drew too far. Okay, a chord. Now a chord, the special thing about a chord is it goes from one point on a circle to another point, but the important part is not through the center. Okay, that's the important part. It goes from one edge of the circle to another edge of the circle, but not through the center. So it can be a short little one like this. It can be really close to the center like that. Hopefully straight, but not actually through the center. Now, compared to that, the diameter does go through the center. Okay? So here's your center, and we have a radius this way, and directly 180 degrees the opposite direction this way. That's why the diameter is equal to 2 times the radius. And we've talked about this already before. The radius is half the diameter. That's another way to look at it. Go ahead and add that, please. They do have that relationship. 2 radii make a diameter, and if you cut a diameter in half, you have a radius. And now, building on that, we have the chord, edge to edge, down through the center. Diameter, edge to edge, but through the center. And then you have a secant. And the secant does not have to be on the edge. So the secant does connect 2 points, but it can continue outside of the circle. So if you think about it, a secant actually contains a chord. Okay? A secant contains a chord. So up here on the first chord, I could actually continue through and overwrite a secant over the chord as I just keep going outside the circle. The chord has to stay within inside the circle. A secant does not. I know it can be a little bit confusing, but just want to clarify that. Okay, now a tangent. Now this is not the same kind of tangent we've been talking about with, trigonometry. We're not talking about opposite over adjacent. No TOA here. Tangent is a line in the plane of a circle and that's just a fancy way of saying it's on the same piece of paper. That's the geometrical way, but if the circle's on the paper, then the line's on the paper also. It's not, intersecting through the paper, cutting through the paper. It's on the paper. That intersects the circle at exactly 1 point. And that point is called the point of tangency. So I know when you look at this picture, that line there, which is the tangent, looks like it hits the circle at a bunch of different points. But there is specifically, if you could go with like a microscope, an electron microscope, and blow this up, there's actually only one exact point where it touches the circle. Even though it looks like it's leaning up against a bunch of the circle, it doesn't. It's actually only touching one specific point. So now here, line segment AP is tangent to circle O. That's how we do a circle. We actually literally draw a circle, put a dot in it, and then put the letter of the center next to it. So it's kind of redundant having an O, but if the O was a D, then we would say that's a way of saying circle D. Now, circle O is tangent to AP. So the line segment is tangent to the circle, and the circle is tangent to the line segment. And A is the point of tangency. That is the point where they touch. And only at that point. Okay, central angles. We've been talking about this already. We've talked about central angles. Okay? When we were doing our apophthegms. And we know that the sum of the central angle of a circle is 360. That's why when we were doing the regular polygons, 360 degrees, we always divide 360 by the number of sides in the polygon. Well, that won't work here with the circle, obviously, because there are no sides. So, in the second picture, central angle 1 plus central angle 2 plus central angle 3, all different, add up to 360. They form a circle. Like I said, you already know this. Now, what we have not discussed is what's called an arc. Oh, I forgot something. I am so sorry. Up here under central angles, I forgot to define it, because we kind of already have done it. It is an angle in a circle that has vertexes, that has a vertex at the center. So here's the center, and there's your vertex angle, which we also call a central angle because it's inside the circle. All right, now an arc. It is the portion of the exterior of the circle. So a central angle separates the circle into two arcs. Okay? Now we've complicated it, not completed, complicated here by having extra things here. But if we just look at the WY, right here we have an arc. And that's called a minor arc. An arc of a circle whose measure is less than 180 degrees, labeled with 2 letters. Okay? And then we also have a major arc. The other part of the circle, right there, that's a major arc. And that's labeled with 3 letters. And a semicircle, which we would have, if we look here, right, from here to here, because that's using the diameter there, a semicircle is also labeled with 3 letters. Okay, inscribed angle. Wow. Board is not being cooperative at all. Here we go. An inscribed angle. It says name the arc that each inscribed angle intercepts. Now, an inscribed angle is inside the circle, but not starting at the vertex. So BAC, let's look at that. BAC BAC. BAC. That's this angle right here. So to find the arc made by that, it's right here. It's this piece right here. It's kind of like if that was a piece of pie, that would be the crust. Or a piece of pizza, that's the crust grain. Okay? So that is BC. And we use this little arc mark to denote that. All right? Now, BAD. BAD. Now notice, yes, the C is there in the middle, but we're ignoring like it's not there because that is not a major arc. That's still not more than half the circle. That's not more than 180 degrees. So, that is BD with an arc mark. And then DAC, which is right here, piece of pie crust or piece of crust right there from D to C with an arc mark over it. Okay, now we have a whole lot of stuff going on. Point O is the center of the circle. Name each figure. OM. Well, OM goes from the center to the outside of the circle, the edge. That makes OM a radius. MN goes from one edge of the circle to the other edge of the circle, but not through the center, which makes it a chord. Now MQ overwrites and keeps going past N to Q. And actually says it's a line segment, so a line out of segment. So you could visualize it going back this way also. So since MQ is going outside of the circle, that is a secant. ML, which is completely outside the circle, right here, touching at this point M, is a tangent line. And if you think about it, you may have heard somebody say, man, they went off on a tangent. You know, like the dog in Up, squirrel. So that's because, you know, a point came up and they just went off in another direction. Well, that's what's happening here. This line is going off from that point M. Now MP, where's that? Well, here's M, across to P, through the center of the circle, making MP a diameter. And really there should be a line segment over that, as well as OM. Now, ROP, getting kind of messy up here. R to O to P. That's this right here. Okay? Well, it's an angle with its vertex at the center, which makes this a central angle. And you know it's an angle because it has the angle symbol right here. I'm going to use a different color because it's getting a little crazy here. N to M to P. And that's an angle inside the circle. But notice the vertex is on the edge, not the center. And we know it's an angle, so it's an inscribed angle. So think about it. To scribe is to write something. You hear about the old movies when they had a scribe who wrote everything down for someone. And in, well, that means in. So you're writing inside the circle. You're making the angle inside the circle. It just doesn't have a vertex at the center. And then RP, which is out here, less than half the circle, less than a semicircle, which makes it a minor arc. And you know right here, that's an arc mark. And we don't have it on here, but if we did, let's add it. If we had arc, R, P, N, 3 letters, that tells us something. So R through P, up here to N, circle, so that would be a major arc. Go ahead and add that. And we're almost finished. So, name each of the following. Almost there. Chord. Well, it has to go from point to point on the circle, so that's EC with a line segment. The center is H. So we put a dot H, point H. The radius, well, the most obvious one is here, HB. But technically, you could also say HA or HD. Because that is a radius. That is a radius. Now, AD, jumping down to number 5, AD is a diameter, but you could cut it up into two different pieces, HA and HD. And the circle, remember, we actually draw a circle with a dot inside of it, and then we just say the letter at the center, H. And one last problem. If a donut has a radius of 3, find the diameter. Well, remember, the diameter is 2 times the radius. So the diameter, 2 times the radius of 3, the diameter is 6. And the circumference, which we already know that formula, the circumference is 2 pi r, or pi times diameter, because 2 times r is d. Well, we know the diameter is 6, so let's just jump to that right now. 6 times pi, and that would be an appropriate answer if we wanted to leave it in terms of pi, or 6 times 3.14 is 18.84 inches, and this would be 6 inches. And we are finished.